Hello and welcome to another session of Blackboard. We are going to look at the move zeros challenge. So with this challenge, you're given an array of numbers or integers 3, 12, and you are supposed to move all the zeros to the end. So we're talking about these zeros coming to the end of the array and then still maintaining the order of the rest. So it's like you're bubbling these zeros to the top and these ones maintain the same order, 12 and then 0, 0. So this should be your solution. So that's the challenge. We have two approaches that we can do this challenge. One is we can have a pointer, call it left, that starts at the beginning, and you have the normal iterator I. So you're doing that for I equals to 0, I less than the size, I plus plus. So we have this iterator I starting, all of them starting at the beginning. So we talk about this is our left and this is our I. But left will only be moving after you get an non-zero number. So the first I, we start here, we do nothing, and when we come across a non-zero like here, now when I is at this point, we move to this point, we swap, not really swapping, but we move this one to where left is, and we increment left. So basically we are ending up with this is our, so this, if this is our first, now at this second position we have 1, okay, and we have 1 still, we're not swapping, we have 0, we have 3, we have 12, okay. So at this point left, we increment left to this point, so left comes here, that's our left, and then now remember i's are now at this point at the top. So I here, it's still non-zero, so we keep moving I plus plus, remember here, I plus plus, we are moving now I here, and we come across a non-zero number, just 3, and then this 3, we just move it to where left is, okay. So if we move that at this point, we'll be at 1, 3. We overwrite whatever is on that position because we know already we moved it, so we're not losing anything, and the rest remains as it was, okay. Okay, now I is going to the last position here, and remember our left now has moved to this position. This is our left now, because we're only doing left plus plus after we've moved something, okay. Now I, it's at this position, and then I is a non-zero, okay, or I mean num I is a non-zero. So again we do the same thing, move. So at this position point 4 will be at 1, 3, and now whatever is here we're overwriting with 12, and then the rest remains the same, okay. Now we are at the end of the array, so that's the first pass. And left, remember left, after writing here, left moved to this position. Now left is pointing here. It's very important to note where the last left is. This is left. And now we are doing the second pass. The second pass is simple. Where left was, up to the end of the array, we overwrite it with zeros, okay. So this is the second pass. So second pass, running from left, where the current left is, to the end of the array, so size minus 1, okay. And we just get, just do one operation, one loop, which is this will remain as it was, and then we are overriding, overriding everything here, which is now will be 0, 0, and now we have our solution. Okay, now let's write the code. So the code, always we're doing it with JavaScript. For those who are new to this channel, we have reasons why we use JavaScript. Very straightforward, simple language, and easy to translate to any other language that you know. So let's do it. So our function is move zeros. Takes in an array of nums, integers. So we say the first pass. First pass is for let left equals to 0. Sorry about that. We initialize left first to 0. I'm sorry about that. So left equals to 0. So let left equals to 0. Let left equals to 0. And then we run our I now. For let I equals to 0, I less than the length, which is nums dot length, then I plus plus. So remember, this is the running that we were doing here. This I moving all this across. And then we are checking if I is an, or whatever I is pointing to is an non-zero. So if nums I is a non-zero, it's not equal to 0, then we are moving it to, we're moving that to where left is. Left. But remember, after moving it to left, we are incrementing left, so we can do it in one operation. The same here equals to nums I. This is as good as, for those who might need some explanation, this is as good as doing nums left equals to nums I. After doing that, then incrementing left. So this we're doing it in one pass. Okay, let's continue. So if that's the case, we move it, and then that's the end. We finish that, and then we run another second pass here. Now this is the part we were talking about. This one, this part, sorry. This is the part where we are overwriting all the rest with zeros. So we move it. So for let I equals to left. Now we're starting from where left was, and then where I up to the end. Nums dot length I plus plus. Okay, and then we just overwrite everything here with zeros. And that's the algorithm. But if you've noticed, like, there's a weakness to this algorithm. Still, the time complexity of this algorithm is order n, okay, but it's not suboptimal because we're still doing two ends. Basically, if you were to collect this is order 2n, okay, but 2 is small, so we just remove it and it becomes n. But we're still doing twice, which is not suboptimal. There's a way we can still do this in order 1, and I want to leave this as your challenge. Have a look at it, but we'll cover it in our next session. Thank you. Have a good day.